Good day, viewers, and welcome back to my YouTube channel. I am on the best educational consult. Thank you so much for sharing my video and commenting on my video, giving the video a thumbs up. I would really appreciate more if you share my video to everybody around you. What we have today is physics. We're going to look into measurements and units in physics. Now, physics. When we talk about measurements, but before we go to measurements, we talk about the fundamental quantities, the life quantity, and the dimension, and also their units. You understand? We're going to look into 1, 2, fundamental quantity and unit, derived. 3, dimension. These are the things we're going to look into one after the other before we can now batch to measurements of the fundamental quantities. Now, I want you to understand one thing here. When we talk about fundamental quantity, we are talking about fundamental means basic. It means what? Basic. Like for instance, you can't start building a house without foundation. So fundamental quantity is all about the foundation of a house. When we talk about fundamental, we're talking about the basic, the foundation. It is called fundamental. You understand? They are the basic quantity. They are the basic quantity that other quantities depends on. You understand? They are called the foundation of a building. You can't start building a house without laying a foundation. Foundation is where your house, your building depends on. So fundamental quantity is all about the basic quantity. They are the basic, they are the foundation of other quantities. This man called the life are gotten from fundamental quantity. This man called dimension are gotten from fundamental quantity. Do you understand? Do you understand? So this man, the difference between the life quantity and dimension is that the life quantity, you can't get the basic quantities. Do you understand? You derive it without giving you the basic, the whole three-dimensional basic quantities. But in dimension, you are going to get the whole three-dimensional basic quantity. Do you understand? So we're going to look into it one after the other. So I want you to understand that this quantity is the foundation of a building. Is the foundation of a building. If you know that this man is the foundation of a building, you will do well in your exam. Do you understand? The coding is that fundamental quantity is the foundation upon which other quantities depend on. This one I gotten from fundamental quantity. This man I gotten from fundamental quantity. All these the life quantities are gotten from fundamental quantity. All the dimensions are gotten from fundamental quantity. So when we talk about fundamental quantity, we are talking about the basic quantities upon which other quantities depend on. You understand? So that's what we mean by fundamental quantity. Quantities. They are the basic quantities upon which other quantities, example, the life, and dimension, are gotten from. Another name for fundamental quantity is independent quantity. You can still call them independent quantity. Another name for fundamental quantity is independent. Another name for this one, fundamental quantity, is independent quantity. It simply means that this man does not depend on any quantity. Other quantities derive their formula from fundamental quantity. Do you understand? So it's an independent. Do you understand? So fundamental quantity, they are the basic quantities upon which other quantities, examples like the life quantity and dimensions, are gotten from. Do you understand? So another name for fundamental quantity is independent quantity. Do you understand? So once you understand that fundamental quantity, they are basic, they are foundation upon which others depends on. You understand? Without fundamental quantities, the life and dimension cannot be gotten. So now, let's go to examples of fundamental quantities. Examples of fundamental quantity. I want you to know one thing here. They are grouped into two: basic and minor example, or major example and minor example. You understand? Major and minor. Now, No two things. The major examples are into 3. The minor are into 4 or 5. Do you understand? No this and no peace. No this and no peace. Fundamental quantity cannot be derived. They don't have any formula. They are independent. That's how to know a fundamental quantity. For example, you can't get a formula of a mass. You can't have a formula of a time. No formula for length. They are called fundamental quantity. You understand? They are independent. They are independent quantities. So the major ones are mass, length, and time. So now the minor, this is where you talk about the temperature. You talk about the electric current. You talk about the temperature, electric current, amount of substance. You understand? These are the examples. You can talk about the intensity of light. Do you understand? So these are the basic fundamental quantity. It's like somebody, you married your first wife give birth to mass, length, and time. So those ones are the basic. Then you marry second wife, the second wife give birth to temperature, electric current, amount of substance, intensity. Do you understand? So this one are the minor quantity. So once you know this, you know peace. So in JAMB, they will ask you, one of these is not a fundamental quantity. You check this and you check this. Do you understand? So these are the fundamental quantities. They are the fundamental quantities. Let's go to their units. Units of fundamental quantity. 1, we talk about mass. The SI unit is what? Kilogram or kg. 2, we talk about length. Meter. We talk about time. Seconds. We talk about temperature. Kelvin. We talk about electric current. Ampere. Amount of substance. Mole. Intensity of light. Candela. So now, this is the examples of fundamental quantity, and this is the example are their units. When we talk about mass, the unit is kilogram. We talk about length, the unit is meter. We talk about time, unit is second. We talk about temperature, the unit is Kelvin. We talk about electric current, the unit is ampere. We talk about amount of substance, the unit is mole. We talk about intensity, the unit is candela. So now, understand that fundamental quantity, these are the basic quantities upon which other quantities depends on. They are being derived from. Do you understand? The basic quantities, mass, length, time, temperature, electric current, amount of substance, intensity are the quantities. So now JAMB or any exam you're writing, OBJ or theory, if it is theory, they will ask you what is fundamental quantity. List out the 5 fundamental quantities you know. That is why you list mass, length, time, temperature, electric current. Now JAMB, they will ask you one of these is not a fundamental quantity. Once these are not in the option, all those one not in the options are the live quantity. Anyone here is a fundamental quantity. Do you understand? So these are the fundamental quantity. They are the basic quantity. So now, let's go to the live quantity. When we talk about the live quantity, we are talking about a quantity that those quantities that are independent on fundamental quantity. For example, velocity, the formula are derived from fundamental quantity. Do you understand? So velocity cannot stand on its own, unlike mass, length, time. Because mass, length, time, there is nothing like formula. So this one that has formula are called the live quantity. Do you understand? Like for instance, let's define it. There are those quantities that are derived from fundamental quantities. It is also called dependent quantity. Another name for the live quantity is called dependent quantity. The live simply means to get something from fundamental quantity. They cannot stand on their own. Do you understand? When we talk about the live quantity, we're talking about the quantity that depends on fundamental quantity. Do you understand? They have a formula that have been derived from fundamental quantity. You understand? Why fundamental quantity is an independent quantity. You understand? They don't have any formula. Like rent, no formula. Time, no formula. Mass, no formula. Temperature, equivalent, etc. You understand? Why derived quantity are those one you are gotten from fundamental quantity. You understand? Examples of the live quantities. Velocity. Number one is velocity. What is the formula of velocity? That is displacement over time. The displacement is all about length. Now look at the board. Are you not seeing that this one, you got this one from the fundamental quantity, meaning the fundamental quantity, length and what? Time. Do you understand? So fundamental quantity are the basic quantities upon which other fundamental quantity are the basic quantities upon which other quantities are being derived from. While derived quantity are they are dependent quantity that are being derived from fundamental quantities. Like for instance now, velocity cannot stand on its own. It depends on length and time. You understand? You understand? So let's look at the SI unit of velocity. Length, the fundamental unit of length is what? Fundamental unit of length is what? Meter. This one is over time. This one is second. That is why you say meter per second. This is the SI unit of velocity. So all other ones are under fundamental, are under the live quantity. Let's give another example. Acceleration. The formula is change in velocity over time. Do you understand? So know the formula, change the velocity over time. Now our velocity is displacement, that is length, over what? Time. So now, because we are talking about the SI unit, to get the SI unit. So since this one is changing velocity, displacement over time, so our acceleration will be displacement, which is equals to length, everything over time multiplied by time. Because our initial formula for velocity is, for acceleration is change in velocity over time. Then our velocity is displacement over time. And the SI unit of velocity is meter per second. Do you understand? Because meter is length measured in meter. Remember our fundamental quantity. Second is time. because of this over per second. You understand? So now our acceleration now is change in velocity over time. Now our velocity is displacement and over time. That is why time we have to time here. Do you understand? So now the SI unit will be, this one is what? The length is what? Meter. And this time is double. So we have per second square. That is the SI unit. SI unit of acceleration. You understand? So the life are gotten from fundamental quantities. You understand? Fundamental quantity are the basic quantity upon which other quantities depends on. While this one are dependent quantity that are being gotten from fundamental quantity. They have their own formula, unlike fundamental quantity. Let's go to dimension. When we are talking about dimension, we are talking about a quantity that can be gotten from the three basic what? Three basic fundamental quantity. You understand? Three basic fundamental quantity. That is what we call dimension. You express the quantity in terms of fundamental quantity. But the fundamental quantity we are talking about are the major fundamental quantities. Do you understand? This one is all about when you express the quantity in terms of the three basic fundamental quantity, or when you convert the quantity to the three basic fundamental quantity. It is called dimension. Expressing quantity in terms of the three basic or major fundamental which are mass, length, and time. This is the definition. You are expressing a quantity in terms of the three basic or major fundamental quantity, or you are converting a quantity to the three basic or major fundamental quantity. It is called dimension. It is called what? Dimension. Let's use an example to illustrate what we mean. Examples. Now look at the board. We take number 1, velocity. The formula for velocity is what? Displacement all over what? Time. And the displacement is all about the length covered. Do you understand? Displacement is also distance. They are talking about length covered. Even the ladles, they are talking about the length. You understand? So now, this one now is all about the length. Remember that we have three fundamental quantities, which are three basic fundamental quantities, which are length, time, and mass. So in dimension, you are trying to convert this thing, the formula of this thing, to either length, mass, and time. You convert everything to length, mass, and time. That's what they mean. They mean that you are meant to convert everything to length, mass, and time. So now, when we look at this stuff, velocity, we have seen that it is equal to displacement, that is length, over time. We have converted the velocity equals to length and then what? Time. Do you understand? So velocity now. Length over time. You have gotten the dimension, which simply means now you change it to L T minus 1. Remember that this is over, it simply means minus 1. So this is the dimension. This is the what? Dimension. Dimension means to convert a quantity to either length, mass, and time. You are converting them, they must change, the structure, everything must change to length, mass, and time. Do you understand? Once you have not gotten the length, mass, and time, you keep on converting until you got length, mass, and time. That's what we call dimension. Dimension is all about converting until you get length, mass, and time. Like this velocity, the first of all we get length and time straight. But let's go to acceleration. Let's go to what? Acceleration. Hope you understood this. Let's go to the second one. The second one, acceleration, which is equal to change in velocity all over time. Remember that dimension is all about converting the quantity until you got length, mass, and time. Either you got two of them, or one of them, or three of them. Do you understand? You must convert it to length, mass, and time. Either length and mass, or mass and time, or mass. Only of them is okay. Do you understand? But the expression must be in the basic fundamental quantity. That's what they mean by dimension. Do you understand? So here now, acceleration is change in velocity over time. We have not, this velocity is not a fundamental quantity. It's talking about the life quantity. And dimension is telling us to change the structure of all the formula about acceleration until you get length, mass, and time. So now we change this one. So acceleration is equals to velocity. What's the formula of velocity? Displacement over time. So we now have displacement all over time, the first time, multiplied by time for velocity, the second time. You understand? Now we look at the board. Displacement is equals to length remember that dimension is all about changing the whole structure, the whole formula, until you get length, mass, and time. You stop. Once you are not getting it, you start changing until you get it. You understand? That is dimension. So now, in the first one, they ask you about acceleration. The first one you get is change the velocity over time. We have gotten time. So time is among the fundamental quantities. It's among the basic fundamental quantity. But velocity is not among. You now convert velocity, which is displacement over time. You now bring out the another time. That is the first time. This is the formula for velocity, which is displacement over time, and this time. Do you understand? So now, our acceleration now is length over time square, which is equals to L T square. Do you understand? This is our dimension. This is what we mean by dimension. Do you understand? Well, let's take another example. Let's go to force. Which is equals to force is equals to mass multiplied by acceleration. Remember vividly that you are changing everything to length, to mass, length, and time. That is your code. So now we have gotten mass, remaining what? Acceleration. You understand? So you now convert the acceleration. So force equals to mass times acceleration is change the velocity all over time. So we are still looking for velocity. Remember that dimension is all about converting until you get mass, length, and time. So now we still convert this one. Force equals to mass multiplied by change the velocity is what? Displacement. Which is equivalent to length all over first time multiplied by time of the velocity second time. So now our force will be mass times length all over time times time, which is time square, is equals to mass length over t square. Do you understand? So which is equals to F equals to M L T minus 2. So do you understand? So dimension is all about changing the whole formula of that quantity until you get your length, mass, and time. Had it been they ask you something like mx ly t z, they ask you to find the value of x, y, and z. What will you do? The value is from here. This one means 1. X is equals to, this one means what? You understand? Y equals to 1. So t means minus 2. you understand? So let's go to, this is formula of a gravitational force. Force constant times first mass and second mass over distance square. Now they're asking you to find the gravitational constants and express it in m, x, l, y, and tz. So this is dimension. This is what? Dimension. What will you do? You make this the subject formula by what? Cross multiply. Once you do it, you get your force, gravitational force, and r square equals to g, ma, and mb. So now you divide this by ma and mb to get g. So when you divide, so this will cancel this. So because we want to get this, they ask you to get the gravitational force, the gravitational constant, and express it in mx, ly, and tz. So now you are getting it. The formula for this one is G equals to F force, gravitational force times R square all over M1, M2. So now you have gotten your mass, two masses. You have gotten your reduced distance, which is L square. It remains the force. So now our force is what? Mass times acceleration times the L square, everything over M square because of 2m. So now we convert this acceleration. What we get is what? G equals to mass times acceleration is velocity, change in velocity all over mass square, change in velocity over time, times time of the acceleration times r square, which is equals to, we are trying to get the velocity. Now we got mass times velocity. Change in velocity is what? Displacement, which is equals to length times r square, everything over m square times time times time. Do you understand? So now you have expressed this. Do you understand? So they ask you to get gravitational constants. Remember that the gravitational force is gravitational constants times first mass times second mass all over r square. Do you understand? Because they ask you to get the gravitational constant and express them in this form. So what will you do? You make this man the subject formula. The first thing you will know the whole formula in physics. So that when someone asks you dimension, you change that stuff until you get length, mass, and time. So now what we do is that we change this man, we make it the subject formula. Once we make the subject formula by cross multiplying, you get something like this. G equals to this after the whole thing. So now, from here, you notice that this is 2 mass. That is mass square. This is force. And this is radius, which is equal to length. Length square. Do you understand? So now, we have not gotten force. You now break force down. So force is mass times acceleration. Do you understand? We are now getting mass, remaining what? Acceleration. You now break acceleration down again. We now got acceleration is equal to velocity over time. Do you understand? You now bring this one or this one down. You break acceleration down again because acceleration is still there. Remember, in dimension, you want to express everything, all these things here. You want to change them until they are length, mass, and time. Do you understand? That is dimension. Here we are getting mass and the what? Radius, which is length. Remaining this one, force. So force is not a fundamental quantity. You change it until the whole formula is length, mass, and time. Dimension is all about changing the formula until everything is length, mass, and time. Do you understand? So here now, we have only length square and mass square. We have gotten length and mass, remaining this. You now change this formula. You now change this one. We changing this one from here. We got this one is mass times what? Acceleration. We have gotten mass, we have gotten radius, we have gotten mass. Remaining acceleration. We now change this one again. We got change the velocity over time. We bring these ones down. Remaining velocity. The velocity now is displacement or length over time. So we now bring other ones down. So that's why we got this. You understand? So look at the board. Remember, they ask you to express this in mx ly tz. So now we are getting this. We are at here. So gravitational constant equals to m. This is length. L. This is another length times L square all over m square times t square. You understand? So remember, this is the formula we got for gravitational constant. So, but because of this is radius is length, distance is length, displacement is length. So this is radius, so it is length square. But force is not a fundamental quantity. That is why you convert force. You change the formula to get the fundamental quantity inside force. Now force is now mass times acceleration. Do you understand? And now we are getting mass, length, remaining acceleration. Do you understand? So now you take the formula for acceleration, which is velocity over time. We have gotten time, mass, length, remaining velocity. We now change velocity again. We now get velocity is distance or length or displacement or length over time. We now bring all the other ones there. Do you understand? So this thing simply means, dimension means to convert until you get length, mass, and time. So now as we have gotten this, so let's check. M, we cancel 1m. We have 1m. Nothing we cancel again. So what we have here is L cube all over m t square. Do you understand? So now we are going to express it as, this is m minus 1. L is what? Cube. This is 2. T minus 2. You understand? So our x now is minus 1. Our y now is 3. Our t is minus 2. You understand? So this is our stuff. This is the answer. You understand? Thank you so much for watching and sharing my video to everybody around you. I really appreciate for that.